All right, welcome everybody to Lab Day. We're going to be working on times table, and this is going to be like a difficulty 3 or 4 assignment. Waru was about a 5 on the difficulty scale. So the secret to times table is understanding doubly nested loops. So your basic pattern for a doubly nested loop is something like this. You have a for int I equals 0, I is less than 10, I plus plus. Now if you're doing a range of numbers, like if you want the numbers to go from like, I don't know, 5 to like 8 or something like that, then you use this pattern where that's the starting number less than or equal to the ending number, which you're probably going to use on this one. And then the inner loop, we use j. We always use j. We always use I for the outer loop. We always use j for the inner loop. And if we have a triply nested loop, it's going to look like this with k. It's just the law. This is just required. You have to do it. So maybe we can get a little bit of intuition with doubly nested for loops here. So let me do something like this. Count equals 0. Count plus plus. Cout count. So how many times is this line going to run? Okay. So the first time through the loop, I is going to be equal to 5. Then we come down here, we create a for loop that's going to run with j equals 2, 3, 4, 5. Then after we finish with j equals 2, 3, 4, 5, we finish that loop there. We come back up here, I is now 6. So I is going to start at 5, then do j is equal to 2, 3, 4, 5. Then I is going to be equal to 6. Then we do j is equal to 2, 3, 4, 5. Then j is equal to 7. We do 2, 3, 4, 5. We do I is equal to 8. 2, 3, 4, 5. So we're going to do how many? What number are we going to print out here? How many times does the outer loop run? And we're going to multiply that by how many times the inner loop runs. So the outer loop, yeah, see, this is why the standard pattern is nice, because you know exactly how many times it's going to run. We have, when you use this pattern here, you're starting at 5, you're going up to and including 8. We're not going less than 8. We're going up to and including 8. I is going to have values of 5, then 6, then 7, then 8. It's going to run a total of 4 times. If we had this be less than 8, then it's going to run 5, 6, 7. It's going to run 3 times. And each time the outer loop runs, it's going to run the inner loop. How many times does the inner loop run? What do you guys think? I'll put this back. 4 times through this one as well. 2, 3, 4, 5. 4 times. So 4 times, it's going to run the inner loop 4 times. And if we run it, you see we get 16. So this line here runs a total of 16 times. So let's put in some different numbers here. I is equal to 0. I is less than 300. How many times does this line run now? See if we can develop some intuition as to how for loops work, doubly nested for loops work. Each time the outer loop runs, it runs all of the iterations of the inner loop. So the outer loop runs 300 times, very good. And then each time the outer loop runs, it runs the inner loop 4 times. For a grand total of 1200. Okay. Voila. All right, let's do one more. How many times is this going to run total? Negative times. So first time through the loop, I is 0. Then it's going to run this loop. It's going to create a variable named j, set it equal to 2. And it's going to check and say, hey, is 2 less than or equal to -5? And the answer is no. So it skips over and then goes back up to the top of this outer loop here. So this inner line here, the count plus plus, is going to run 0 times. Yep. All right. How about we do 11 to 16? How many times is this going to run? I'm going to have to count my fingers and toes. Okay, I got it. A number. All right, the inner loop here, it runs 7 times. First time through the loop, it's 11, then it's 12, then it's 13, then it's 14, then it's 15, then it's 16, then it stops. So j goes from 11 to 16. So 6 total. The outer loop runs 300 times. So 300 times, it does 6 operations. So there's a total of 1,800. Off by 1 errors are very common. Yeah, don't beat yourself up over it. It's exceptionally common to have a fence post error and off by 1 error. Okay. So now let's maybe do some actual times tables up in here. So we'll do from 1 to 10, from j equals 1 to 10. Now, you know, let's make this a little more interesting. We don't have to start at 1, you know? Nobody's my boss, right? All right, so cout I times j, followed by the tab character. And then after the row is done, we'll output not count. Just d2w, just the end. Okay. And so this is going to give us the times tables from 5s to, what's that? Whatever it is. What are we up to? 12? Yeah. So this is your assignment. So if we come over to see the elementary part 2, you'll see that times table going from 1 to 10 is your classic 1 to 10 times table here. So 6 times 7 is 42, the most important number in the world. My wife's 42nd birthday is today, in fact. So, it's a magic number in computer science. We use 42 for a lot of things. So, in addition to a times table, though, you're going to have to do a division table. So if we go from 1 to 10, you'll see that the number 8 divided by 2 is 4. Thank you. Yeah. I'll pass on your warm regards. So 10 divided by 7 is 1. It's integer division, right? We're not doing a floating point division. And these numbers can be negative. So we can have from -10 to 0. And what you'll see here is we get something called nan. So nan is, or non, depending on your pronunciation. Back in nan or non-bread, one or the other, however you pronounce it, it's all good. It means not a number. So if you take 5 and divide it by 0, you get nan or non, whatever. Okay? And so this is not a bad input. This is not going to cause your program to die like it normally does. You just print non to the screen. Okay. So here we got -10 divided by -10 is 1. -10 divided by -1 is 10. Yeah. So the numbers can be positive, they can be negative. Just be careful when you're doing division by 0 and when you're doing modulus by 0 to output nan like that. So we do modulus. Let's do modulus here. From -5 to +5, you can see that -4 modulus 0 is nan. -4 modulus -2 is 0, because -2 divides into -4 2 times with the remainder of 0. All right? Now, you might notice we're getting negative numbers here, and that's kind of weird, isn't it? Like you can't have a negative amount left over, and that's just one of those oddities of C++. When you do modulus with a negative number, it'll give you a negative remainder instead of sort of properly doing the modulus, which is counterintuitive to how most people think it should work. That said, it's not an error. Like, this is correct, at least according to C++, so don't try and fix it. Personally, I would want there always to be a positive remainder, right? Because, you always should have a positive amount left over, but c'est la vie, that's how C++ decides that modulus works. And that's your entire assignment. So you got 5 options: addition, subtraction, multiplication, division, modulus. The numbers, you can put in any range. The maximum size of the table, I think, is 21. You might have to shrink your font down to get it to fit. You're going to print tabs between every character. If you guys remember how to print a tab, it is single quote, \t, single quote. Now you might be like, but wait, isn't that 2 characters? Single quotes are for single characters. Yes, actually, \t is a single character. Just like how \n is actually the special new line character. It is not actually going to print \, and then n. It's literally the enter key. \t is literally the tab key. So that's a thing. If you actually want to print a \, you'd have to do something like this. Anyone know what this is going to print to the screen? I'm printing out 4 backslashes. How many are actually going to appear? Nothing? 2. Because in order to print a \, that's 1 \. You have to put \, to print a \. So if you want to print out \, into the screen, like literally like \, into the screen, then you have to do \, in, and then you get a \, in there, which then might, if you're feeding that into another program, that might turn it into a new line. It's one of those annoying things in computer science. You're like, all right, how many times do I need to quote my characters? It's a \, n or whatever. So, it's a little fun fact there. So \t is just the tab character. This is not 2 characters. This is 1 character. Okay. And so every number you print, just put a tab character between it. You'll be good. Let's see. Sorry. If you make the table too big, 1 to 100, it's bad input. If you make the larger number smaller than the smaller number, that's bad input. So there's, I think, 7 test cases for bad input. You should probably make sure that right. So make sure that the user doesn't type in a word. Make sure that they don't type in a squirrel here either. Like, there's a lot of ways they can type in bad input. We got, I think, 7 O.J. Simpson coding right there. If the \, don't fit, you must acquit. All right, so go. That's it. Begin.